Hi everybody, welcome back. And today for math, we're going to be discussing section 9b, which is using trigonometric models. So previously we've looked at trigonometric graphs, right? And we've looked at the periodic behavior, and we've seen how other things can have periodic behavior as well. And so a lot of times trigonometric models are used to replicate functions out in the real world, and we're going to look at a couple of those examples and how we can use those to make some estimates and conclusions. So the example I'm going to show you first is this one talks about the tides rising and falling on January 24th at Cape Town, and it's modeled after this trig function. So we have h of t is equal to 3 sine of pi t over 6. And t is going to be the number of hours after midnight, so that's going to be 0, and then midnight will be 0, and then obviously we're going to continue through the day through t number of hours, and we're going to look at the range from 0 to 24, so a full day. So let's start by graphing this. So you can use a graph. We know how to graph this by hand, but you can go ahead and use a graphing calculator, or if you don't have one handy, if you want to use Desmos. So go ahead and grab that graphing calculator and hit pause, or if you want to go ahead and pull up Desmos either on the on your smart device, or you can access it through through Clever as well. And I'll wait for you if you want to pause and come on back. Okay, so let's look at graphing this particular model. So when we graph 3 sine of pi t over 6, it's going to look like this graph right here. And you'll notice that, oops, an extra straight line there. You'll notice that the graph has a period of 12 hours, right? So it goes from 0 through 12, and then it repeats itself for the next 12 hours. And that's what's modeling our tide. We also notice that it has an amplitude of 3, so it goes from 3 to -3, and those are going to be the high and low tides throughout the course of this day. So the first question it asks us are, the first question is, letter B here, when is the tide high and what is the maximum height? So what do? Well, we can look at the graph and see what is the highest points on the graph, and that's going to be points A and B, right? And so what time do those occur at? Well, that occurs at 3 and 15 hours after midnight. So as a result, as it says here for B, the high tide will be at 3 a.m., which is 3 hours after midnight, and 3 p.m., which is 15 hours after midnight. Second question is asking us, what is the height of the tide at 2 p.m.? So we're going to go to our graph, and 2 p.m. is when t is equal to 14. And if you look right up here, t is equal to 14. If I draw that graph up here, it looks like it intersects right about there. And if I look at the y values, I say it's approximately 2.6. So at 4 o'clock, we say that the tide is about 2.6 meters above sea level, which is the mean value, the mean sea level at 0. Last question it's going to ask us for, and this is where a good application comes into play, is right here. It says a ship can cross the harbor provided the tide is at least 2 meters above sea level. When is crossing going to be possible? So this is where you would look at that model and say, okay, I want the ship to be able to cross safely because I need a high enough tide so the water's deep enough. When can that happen? So what we're going to do is, in addition to graphing the function itself, which we already did, was 3 sine of pi x. Well, if you put in your graphing calculator, y equals 3 sine of pi x over 6, and also graph y equals 2. Well, what happens is then we get this dotted line across, right? And this is that dotted line, that's that level where the tide is equal to 2 meters. That means that any time when the graph is above 2 meters, which is this area right here, and this area right here, that's when the boat can safely cross. And this point, T1, looks like it's approximately 1.39. T2 is approximately 4.16. And then we'll look at, this in a highlighter, we look at T3, which is about 13.9, and T4, which is about 16.6. So now we know this. What times do those occur at? Well, 1.39, that's not 139, right? That's 0.39 of an hour, right? 0.39 one-hundredths of an hour. So you divide that out, you're actually going to get, it's about 23 minutes. So 1 hour and 23 minutes. So that's at 1:23, and then 4.61, that's about 4:37 a.m. And then the 13.9 and the 16.6, that's going to be 1:23 to 4:37 p.m., and those are going to be the times that make the ship crossing possible. And that's it. So using the graph and using these trigonometric models to answer questions based on the periodic behavior of events that are occurring in the real world. So what I want you to do, I've got 3 problems here for you in section 9b. This is questions numbers 1, 3, and 4. The multiple parts are just the kind of like we did asking questions on the same models. These are 3 different models. As a note here, it says if you're doing this on the graphing calculator, you may have to play around with the y min and y max and the x min and x max so you can see the whole graph. They may be asking for more than one period, so just look at the range, the domain that it's looking at for values, and then set your graphs accordingly. And that's it. Again, if you have any questions, please don't hesitate to ask on the discussion boards. Please feel free to email me a question as well. And don't forget to load your assignment into eCampus. Thank you very much and take care. We'll talk to you soon.